Let's do some problems. In question 1 on this assignment, we're asked to calculate the definite integral from a to b of, more parentheses, f of x squared minus g of x squared, oops, I missed one. Oop, fit it in, saved it, dx. What we want to do here, so 5.4 is all about theorems about definite integrals. And one of the properties that we have with definite integrals is that the definite integral of a sum is just the sum of the definite integrals. So a property of definite integrals says if we have two terms, a definite integral of terms, we could just separate into two separate integrals. This is the integral from a to b of f of x squared dx minus the integral from a to b of g of x squared dx. And the reason that we would want to do this is that we have each of these two values. The integral from a to b of f of x squared to x is 14. This was given. And the integral from a to b of g of t squared dt is 5. So switching it to x doesn't change the value. And then 14 minus 5 is 9. So we just had to split up the definite integrals. That's one of the properties of definite integrals. The definite integral is a linear transformation. The integral of a sum is a sum of the integrals. Any questions? That's it. I do not know why they chose to square the f of x and the g of x. I thought that was a really weird choice, and I have been thinking about this since I looked at this problem yesterday, and I just came up blank with an answer. I want to find out what grad student was tasked with writing this problem. I'm like, oh, dude, why did you square those things? And the only thing I could come up with is that person would say, so that people would send me email and say, dude, why did you square these things? And I think that's funny. So I think someone's just being funny. I don't know why the squareds. It looks like it was there to throw you off. A red herring. Or should I say, a red squaring. So I'm not sure why that is. Anyway, any questions on problem number 1 from 5-4? Great. Let's go and do question 2. Question 2 is a question about average value. So the question 2 is the average value on the interval from a to b. So let's just write down the formula and then talk about the formula. So the average value of a function on an interval is 1 over b minus a times the integral from a to b of f of x dx. This is actually in line with the way we calculate averages of things. If I have all of your test scores, I add up all your tests, and I want the average test score, I add up all your test scores and divide by the number of test scores. I get the total of all the points and divide by the number of tests. If we think about integration, integration is adding things up. This is us continually adding all the values of the function f of x. And then we add up all the values of the function and then divide by the function. So it makes sense that this integration is replacing our sum, since we're looking at a continuous sum rather than a discrete sum. So what we want to calculate in problem 2 is the average value of the function e to the t over the interval from 0 to 8. So we're going to take the integral from 0 to 8 of e to the t dt, and then we just divide by 1 over 8 minus 0. And for this, we can just use a calculating machine. We can just do math 9 of e to the x with respect to x from 0 to 8, and then divide that by 8. I could have done that previously. So 372 points, it says 1 decimal place, so 372.5. Oops. This is also related to the, if we look at the graph of the function e to the x on the interval from 0 to 8. If we look at the graph of the function on the e to the x, it's an exponential function. From 0 to 8. The 2980 is the area under the curve. That's the sum of all the e to the x values between x equals 0 and x equals 8, the continuous sum. So the 372.5 is where we would draw a horizontal line. So if we imagine the average value is 372.5, what is e to the 8? It's a lot. So e to the 8 is 29. Okay. So e to the 8 is like 2980. So yeah, it's e to the x. Minus 5 points for me noticing things. The average value is 372.5. And so what that indicates is if I just take the 372.5 times 8, that gives us the total area under this curve. And so the average value is like, what if it's just flat the whole way through? So the area under the 372.5 is equal to the area under e to the x from 0 to 8. So that's what we could think of as the average value. And that's how the average value will tie to the definite integral in terms of area. Any questions? Cool, let's pause the video here, change pages, and move on to the next problem.